And then what I just want folks to do quickly is just to let me know if they can hear the sound when I'm playing the video. So just let me know if that's going on.
For a community of interest using the QGIS open source GIS software package.
Okay, great.
So if you've been following some of the previous trainings, you will have figured out how to get a community of interest from web app to see how different plans have analyzed different communities of interest. And today I want to show you how to do this using QGIS. The problem with QGIS is it's very powerful, which is actually fantastic for working with some of the data that you can export from your web redistricting app of choice. But it's also a much more complex piece of software and can be intimidating for beginners. And so I wanted to put together a simple presentation to show you how to get your COI data into QGIS and how to analyze it from start to finish. So there's 3 steps, and the first step is compiling all of the data that you will be importing into QGIS, actually importing that data, and then manipulating the data so that you can check to see whether or not the COI complies with or if the redistricting plan and the COI plan are compliant with each other. And these steps are important because compiling the data is really the first thing that you want to do. You want to figure out, this is my community of interest file, and these are all the other files that I want to add, because unlike the web apps, you're going to have to actually add the redistricting plan yourself. You're going to have to add the census block map yourself. We won't be adding the census block map today, but it's something that you might want to do if you become familiar with QGIS, or if you use QGIS a lot, you will, for redistricting, you'll definitely be using block plans. And so having a list and knowing what you need to get into the software, it's much easier to do that from the start. So when you're compiling the data, what's really good to know is that pretty much anything you can export from Representable, Daves, Districtor, District Builder, you can import back into QGIS. There's a couple exceptions. There might be some proprietary save file formats that you might not be able to get back into QGIS, and don't use this block CSV for this. It's a lot easier to export to GeoJSON or shapefile. You can export to CSV and then re-import into QGIS, but that will be beyond the topics that we're covering today. And as I mentioned, there's no built-in redistricting data with QGIS. So everything that you want, you're going to have to figure out where it is, download it, unzip it, and then add it into QGIS yourself. So the data that we're looking for is we're going to want 1 or more proposed or final redistricting plans, and then 1 or more defined communities of interest. And as I've said, any normal spatial file format will work for this. So if you have the information in a shapefile, that's the most common. GeoJSON is the most common for importing or exporting from the web. Most of the information on the redistricting data hub will be in shapefile format, so you won't have to do anything. And what is important to know is that things like Word documents, PDFs, or image files are a different type of file format that can be read by QGIS. So you really want to make sure that you have the actual raw spatial data as opposed to a PDF or a map, because you won't be able to do anything with a PDF or like a PNG or a JPEG of the redistricting plan. So make sure that you have the right file format. To get your final or proposed redistricting plans, today I downloaded the Massachusetts data from Redistricting Data Hub directly in shapefile format. You can also use the block groups on a census, such as Tiger Maps. State websites will frequently provide redistricting maps in good spatial formats. And you can also, I've done this in the past, export the proposed data from Dave's Redistricting. There is a way of getting the actual proposed plans from Dave's into QGIS. We won't go into that today, but do know that it's possible. You basically just export the GeoJSON and then re-import the GeoJSON into QGIS. So there's lots of different ways to find redistricting plans for QGIS, it's not quite as simple as going into one of the programs and selecting the plan that you want, but it's very easy to do once you get the hang of it. Community of interest plans might be a little bit more difficult to find. For the exercise today, I'm using data that I was sent by the Redistricting Data Hub. Tiger block groups are what most of the COIs software uses to have people draw where those maps are. There might be state websites with a collection of the community of interest maps that were used in drawing the final maps. And if you have people who have used Representable and other online COI tools, frequently they will have exportable data that you can import back into QGIS and use to see if a particular plan respected a particular COI. So a couple differences between the web apps and QGIS, if you're familiar with online redistricting software. Those are designed specifically to help you redistrict. They have singular purposes some of the times. They're very flexible. They're great. I would strongly recommend using them. But because QGIS is designed as a standalone open source GIS software package, redistricting is just one of the many things that QGIS can do. There is a QGIS Redistricting Plugin, which I wrote, and it works really well. So if you want to do redistricting completely within QGIS, you're completely able to do so. That again is beyond the scope of today's presentation. One other really important thing about QGIS is understanding projections. Projections are something that you don't have to worry about if you've only used web applications, but they're fundamentally important before you start jumping into using a GIS software package. And a projection is just how a geographic coordinate gets drawn in two-dimensional space. There are thousands of different projections. A lot of these you will never use in your life. The most common one is something called the 4326 projection. So basically there's a petroleum industry list of all of the different projections, and they give all of them a unique ID. And this has been adopted by GIS software packages. And 4326 is the most up-to-date model of the globe. There are many other different ones. A lot of the ones that are different that you will see in redistricting are localized to the state. So basically, they have figured out the most precise model of the Earth for that particular state. And the farther away you get from the state, the less accurate the model is, but it usually is basically millimeter perfect for a lot of different parts of the state. And understanding which projection your data is in is really important. And you don't even really need to know what it means. You just need to know that all of your data ultimately needs to be in the same projection, just to make it easier on you, because as soon as you start doing any sort of spatial manipulation or trying to make layers work with each other, if they're in different projections, you're going to get different results. And I think we'll see today that there's a projection that will cause little slivers of polygons that will not be fantastic, but is a good demonstration of how, even if you can get two different layers, if you reproject one layer to talk to another layer, it's not necessarily going to be perfect, even if they're based on the same data set. With that, let's jump into QGIS and let us compare the communities of interest to the lines that were drawn by the Massachusetts State Legislature. So here we have a QGIS project screen, and I've already added some of the data to this. Normally, when you would open up QGIS, it would ask you to create a new project, which is something that you will want to do. You can also create a new project by going to the upper left-hand corner and clicking on the page icon. It will create a new project, or by going to the project menu and clicking on new. Although I've already added the data, it's very important for you to know how to add data in QGIS. In order to add data, you go to the layer menu, add layer, and for redistricting, we're going to want to add a vector layer. The vast majority, probably all of the data that I work with in a redistricting context is a vector. The other major type of data that you would be working with would be raster data, but that is used for elevation data, continuous data, like a temperature map would be in the raster. It's not something that is used very often. Satellite images are raster data. The other one that you might use are if you're importing a database, or if you're importing a delimited text file, you can use the different types of import packages on the left. QGIS can import massive types of data, but for now we're just going to be using vector, and then you would click on the 3 dots here to browse your hard drive and then add the data that you are after. So I have added from the Redistricting Data Hub the Massachusetts upper and lower house for the state geographies, and then the congressional federal geography. And from representable, I have whether these COIs have been impacted by the plans that were adopted. In Massachusetts, it's unknown whether or not they utilize communities of interest, but this is the data set. It's a good data set to work with. And I actually don't know the answer to this because this is the first time I am working through this particular exercise, but to completion. But the first thing I'm going to want to do is, if you notice on the left in the layers panel, we actually have one layer for every single COI, and I'm going to want to actually join all of these into one file, which is a spatial operation that you wouldn't necessarily be able to do with one of the web software packages. So the vector menu has a number of different things that you can use to manipulate the data that you're using. For now, I just want to merge all of the layers together. So I'm going to go to Vector Data Management Tools, Merge Vector Layers. And so first I'll select all, and then I will unselect the Massachusetts vectors because we don't want to include those. And then we'll just create a temporary layer. But typically you're going to want to save this to a layer so that when you leave QGIS and come back, especially if you save the project, you'll have the data still there. So you'd be basically creating a new spatial file. We'll click destination CRS is important too. So we talked about projections a little bit earlier, and I don't know if you noticed, but it tells you the projection at the end of each file, and all of the Massachusetts files are in a slightly different projection. So 4269 as opposed to 4326. Because I loaded the Massachusetts one first, the QGIS thinks of the project projection is the 4269. So I'm going to want to select 4269 so the temporary layer and the Massachusetts layers are in the same projection. Now, typically this won't necessarily matter because QGIS is smart and knows that you want to have everything match up. But as soon as we start doing processing, you have to have them in the same projection, or otherwise QGIS gets a little bit confused. And this is just an example of why projection is something that you absolutely have to know if you're doing anything in a GIS software package that the web redistricting sort of shields you from. But it's important to get everything in the same projection. So now we'll run. Happen very quickly, and the merged file is in the middle of all of the COIs. So we'll remove all of the COIs. So go remove layer here, remove 9 of them, and then the remainder and remove those as well. And you'll see that nothing changed because all of the merged polygons are now in one, they've been smashed together into one file. So now I'll go over to the layers menu and right click to open attribute table. And because they all had the same database table, we've got a nicely merged together table with all of the information with the cultural interests, economic interests, community activities for every single polygon. So now let's see, the other thing that's important is, so I'll right click again on the layers panel. And if you don't see the layers panel, go up to view and then panels and then layers. That's a very important panel. so that you can see everything, all of the data that's currently in your project. So I'll also go to properties, information, and we'll see that this is in 4269. So now we'll see if the congressional map splits any of these communities of interest. Now, we can already look manually from here, but this is the congressional map. But the thing that we're going to want to do is actually make it very easy to figure out what's going on here. So the first thing I'm going to want to do is go to click on the congressional layer and go to symbology. And this is what the layer looks like. It's been a simple fill color, and we want this to be nice and white. And actually, we want to be no brush. And this basically will make anything that's filled in there transparent. And then for the line, we're going to want the line to be very obvious. And actually, what we'll do is we'll even add a second rule by clicking on the plus button. We'll make that no brush again, and then we'll make a thinner line at 0.26 that's white, and then a 1.06, and then you can dash the line somewhat. So that is our new congressional layer. I don't like the fact it's so white, but for now that's okay. And then we will now be able to zoom in, and we can see clearly now. So what I've just done is moved the merged below the congressional layer, and you can see clearly that this particular community of interest has been bisected federally, and this is the Roslindale community. As a see what's selected, so there's select feature on the toolbar, so now it's yellow, and then we'll right-click the attribute table. Roslindale is a diverse community of people who live in close proximity to Roslindale Center and live, shop, and commute through the area that is currently split in half. So this might have been a COI that was proposed after the initial redistricting, I'm not sure. This particular COI as well looks as if it's been bisected. So now we'll go back to the database table. And this is the Tufts University student. And it looks like the campus is split between two different cities. According to this, this is not the easiest, most easy way to see if we can, but that's better. So half a campus is one district, and the other half is in another district because it's split between two cities. And so the people who drew the map obviously probably made two different cities, or drew the lines to represent two different cities. And so that community of interest has been split. This community of interest has not been split. Or if it has been very... No, it hasn't been split at all. But this one as well has been split just by, this is just the eyeball test, right? Immigrant community of Revere with cultural, economic, and community activities and other considerations. And this has also clearly been split, although just at the bottom there. And so we're just eyeballing at this point, but it's very easy to see which communities of interest have been placed into different federal districts and which have not been split. Like these have not been split, these have not been split, but there are some here that have. So if you wanted to do this in a way that wasn't manual, something that I would do is use a spatial function. So we go to geometry, geoprocessing tools and intersection. So the input layer is merged and the overlay layer is congressional. And we'll just create a temporary intersection layer. And now if we remove all of the other layers and make them all invisible. So I don't know where we are right now, but that's not the point. The point is to see if we now created two different polygons where there was one, but we split the polygon by the congressional district. So right now I'm identifying both of the polygons using the identify tool. And the ID of this district is 5, and the ID of this district is 7. And so if we open up the attribute table again, we can see all of the ones that have been split and which districts they've been split into. So Fall River has been split, Immigrant Community Revere has been split, and this is because they now have multiple entries in the database. Because what we've done is we've taken the congressional layer, and we've created a new layer that has merged the two layers, so that every single community of interest has its own polygon within every single congressional district. So it looks like there's 1, 2, 3, 4, 5 communities of interest that have been split congressionally. So now we'll repeat this process with the state map and the merged layer. So what I like to do is, this is the this is the congressional layer. I was trying to make it visible again. And now, even though we don't want it anymore, what's really nifty in QGIS is to right-click and go to Styles, Copy Style, All Style Categories, and Styles. And I've just clicked on the layer that we want now, which is the lower house. Styles, Paste Style, All Style Categories. And now we have the exact same lines map, but for our house. And so we can see that it's done a better job of maintaining the communities of interest, but maybe not a perfect job. So let's run the same vector geoprocessing intersection. So merge with, I'm sorry, this is the upper house. Upper house, and run. And we will rename this layer intersection upper house. Notice these on the right. These are currently saved in memory, but are not saved to disk. These are temporary scratch layers. So you would have to save these to disk if you want to keep using them between sessions. So now we'll go back to the attribute table, which is the database, and sort. And we'll see that Immigrant Community of Revere has been split, although it looks like it might have been that's actually not a split. That looks like a data error, possibly with a reprojection. So you can see the little sliver here. So even though that is technically split on the data, that's not an actual split. Which is why you should verify. East Boston, again, that looks like a, yep, there it is. And this is because when we reprojected the COIs, the reprojection may have been slightly imprecise to the actual files that were used from the redistricting data hub. So here is a clear split. This is Roslindale. So I've just selected those two rows, and so its comp is yellow. So that's one split. And then let's see if there's any. There's at least two more. So I've selected those rows, and we'll zoom out. And that doesn't look like it's been split. And let's confirm. Yep, that's just split along the bottom line very narrowly somewhere. Yep, right there. That's probably a couple inches of just the data not lining up, and that looks like it's the same case over here. So there's only one split in the upper house. And basically what you're trying to present here is a map like this showing clearly where the COI is and where the community of interest is. And something that I like to do, if you're trying to make this into a final map, is go to symbology and go to categorized, and then set the value as the entry name. And so now all of these are different colors. So what I did was I picked an entry name and then I clicked classify. And the program went through, figured out every single unique name and gave it all its own unique color. Color ramp is random, which is what we want for this. You can play around with the colors if you like. There's lots of different options. And then go to labels, single labels, and the entry name. What I like to do with placement is make sure that the label is inside the polygon under the placement, and I like horizontal better than around centroid because it allows the program to make a better decision about where to place the label. And so now we see all of the different COIs. And we can clearly see that Rossendale has been bifurcated. And this is, I would now clean up the labels a little bit and try to make them a little bit more legible. I'd actually probably change the lines here and add a base layer to let people know where they were, maybe add a roads layer, maybe add an OpenStreetMap layer underneath all of this to actually do the final presentation. But this is, in general, how you would make a community of interest map with QGIS. And that's just scratched the surface, basically. QGIS is a very, very powerful piece of software. There's lots of different data sources you can add. You can add transparency, you can play around with symbology. But if you are trying to figure out how many communities of interest have been bisected or trisected or worse by the maps that have been proposed or enacted, that is how I would do it with QGIS.
Awesome. Give me 1 second. I'm gonna go ahead and stop sharing. I think folks can see me. Awesome. Just actually wanted to answer a quick question from Richard. He asked about where the COI data came from. So we're actually doing a COI collection project currently, and that's actually being run by our data collection coordinators. So I'm actually going to put more information in the chat, but definitely a great question from Richard. So I'll include the page about it in an email if you'd like to learn more information about that ongoing project. So I'm going to quickly do is actually shift it to Connor. Connor, I think you should have the ability to present. Once Connor is done presenting, then we could go into the Q&A portion. Again, if you have folks have any questions, please put it in the chat. I'll be more than happy to answer it. Connor, I'll let you take it away.
Okay, can people see this PowerPoint that I've put up?
Yes, we can.
All right, great. So my name's Connor. I'm with the Redistricting Data Hub. I'm going to present 2 programs I wrote in Python to analyze community of interest. The outcome in some respects is really similar to what we just saw, but a different way of doing it. And then I have a couple other features which may be of interest. This is also, these are the mapping tools that are compatible with my 2 programs. It seems like many of the same ones overlap with QGIS, but it's Dave's Redistricting, District R, District Builder, and Representable. So this is the first program. I've named it COI, or Community of Interest Population Assessment. The point of this one is that if you as an individual are curious to know whether or not a community of interest that you drew or someone else drew was maintained as whole, you can import the community of interest map, and the program will return to you the percentage of the community's population in each district of the enacted plan. So this is just a sample output where I made a community of interest in Arizona, and I imported it into the program, and it told me that 65.8% of the population was in District 2 and 34.2% of the population was in District 3. And it also produces a map which looks similar to the QGIS output, and that outlines the districts of this state or the enacted plan that the state has in place. And this community of interest is overlaid for a visual representation of how that community was split. So this image on the right is the entire state of Arizona, and the deep red color is my community of interest made up of census blocks. And the image on the left is just a zoomed in version of that same photo. And you can see how the community of interest, in this case in Southeast Tucson, is split between Districts 2 on the right and District 3 on the left. Both of the programs employ two sort of mathematical metrics that give information about how much a community was split. The first is an effective split score, and the equation for it is written out here. And basically the idea behind this is that if you have a community of interest that is split once, but 99% of the community is in one district and only 1% is in another district, that's effectively like it was barely split because overwhelmingly the community was kept whole. And a very different circumstance is drawn at the bottom here, where it says a community that's split into 2 equal halves by population would receive an effective split score of 1. So this metric, as the score is increasing, it means that the population was more and more split, or meaning the population of the community of interest was split into increasing numbers of districts. And then the other metric is called uncertainty of membership. And it's very similar to the effective split score, but sort of more humanized. It represents the uncertainty that an individual living in the community of interest experiences when guessing which district he lives in. So if I drew that example district in Southeast Arizona, it would have an uncertainty of membership of about 2, because it wouldn't be quite clear for me which district, either District 2 or District 3, I'd live in, because they split my community by about 1/3 on one side and 2/3 on the other. And this is just another example of the actual scores that my community of interest received. The second program is called Community of Interest Overlaps. This one is a lot more interesting if what you're curious about is whether or not a legislature respected community of interest as a whole. So the way this program works is you can submit to it any number of community of interest maps. In my vision, it would be all of the maps that were submitted to a state legislature when they were trying to draw. Let me just see. It looks like there's a quick. Oh, okay. And the program returns to you a map of hotspots where community of interest map submissions were overlapping. And as more people identify a geographic area as a community of interest, that area's overlap score increases, and that becomes visually very clear. So I can show that again here. I drew a bunch of sample community of interests, and there's a color gradient here. So the darker red an area is, the more community of interest maps identified that area as being a community. So in the Northeast here, if you know Arizona well, you'll know that this is surrounding the area of the Hopi Reservation. So I was just sort of imagining that people on that reservation might have wanted their community to be kept whole in one district. And so 4 different members of that community could have drawn COI maps that were slightly different, but the centers of them all overlapped. And so it should be kind of clear here that if the legislature were able to keep one portion whole, it'd be very valuable for them to keep this dark red portion whole, because so many individuals were submitting maps that said, we think this area should be kept whole. And then the same can be seen again in Southeast Arizona around Tucson. I just made up some community of interest maps, and you can see that a lot of people thought this area should be maintained as whole, but many people thought that the more northern part, closer into the center of Tucson, was more valuable. And then it also, the program also outputs information about these community cores. So in this case, the two darker red areas were exported. I have them exporting to a CSV, but they can really export to any format. And they give the program will give an effective split score of those community cores. So in the case of the Hopi Reservation area, it's pretty clear that all of this was maintained in District 1. And so it received an effective split score of 0, meaning that it wasn't split at all. And then in my Southeast Tucson community of interest, there's a fair amount of population in District 3 and a fair amount in District 2. And so that received actually a pretty high effective split score. And then if you're interested in the future, taking just that community of interest core and manipulating it in some way or discussing it, the CSV will save information about all of the census blocks that compose that core, and then you can go back and play with it. And then the last thing is just the necessary data. It's pretty much the same as what you need for QGIS, and the vast majority of it is on the RDH website. So you need a CSV of your community of interest, which can be drawn on any of the free mapping websites. And I'm also trying to make it accessible with shapefiles or GeoJSONs of your community of interest, which is what is used in QGIS. You need a CSV of the state's census PL file, and that can be found on the RDH website. A CSV of the census block assignments of the enacted plan. This can be found in a lot of places. Dave's Redistricting has started to host enacted plans. A state's redistricting commission's website or the legislature's website will often host these. And then you need a shapefile or GeoJSON of the enacted plan and the shapefile of the state census blocks. And both of these can be found fairly easily on the Redistricting Data Hub's website. So that's all I have for my oh no, I have one more slide. This is just, if you're not really familiar with Python, I've just taken an excerpt of my code, which is just where you're importing these files. And I'm going to explain quickly how you do that in case it doesn't, if that information is needed. But basically, here are the 5 files that you need, 1 through 5, and a little description is given about what that file is. And all you would have to do is download the file onto your computer and put it into the same file where the program is saved. And then you just have to fill in where it says fill in the path to that file. So I put an example at the bottom for the Arizona boundary shapefile. And on my computer, I just put in users, my name, my folder is called PyCharm projects. The inner folder where I'm doing this community of interest analysis is called COI analysis. This is the folder that when I downloaded it from the RDH website, it came in, and then this is the name of the actual shapefile. So I would take all of that in quotes and put it in this area where it says fill in.shape. And then after that, it's fairly simple. You just click run and the program will give you all the information that I just ran through. So if anyone has any questions, I know that seemed like a lot of, okay, sure, let's see. Can you cut the split score versus uncertainty, please? Sure, so I will reshare my screen and go back to that. Okay, so effective split score, I actually think this is the more useful of the two, but PI, so in this bottom part here, is the proportion of the community contained in a district. So you can imagine if I have a community of interest that was split perfectly in half between 2 districts, PI for the first district would be 0.5 because it has 50% of my community of interest. And then the PI for the second district would be 0.5 as well. And this symbol here means just the sum. So if you were writing this out by hand, you do 0.5 squared. And then because it's summed, you do 0.5 squared again to represent the other one. And then you do 1 over that and then subtract from 1. The value of this effective split is that it's not just telling you how many times your community was split, if any, but it's telling you meaningful information sort of quantitatively about that split. So there's an example here at the bottom that if a community was split in half, perfectly even with population on either side, it receives a higher split score, meaning 1, because that community is not going to be as represented by each of those districts because each district has half of the community's population. But if the community is divided into 2 components where 90% is in one district and only 10% is the other, it receives a much lower effective split score because there's still going to be a fair amount of representation of that community in the district that has 90% of its population. And then uncertainty of membership is similar in some respects. You still have this PI, which is the proportion of the community contained in a district. And it's just sort of a reframing of a similar idea. And so this score represents the uncertainty that an individual in the COI might experience when they're guessing what district they've been placed in. So in my example in Arizona, if my community were all around Tucson here and about 33% and about 66% is contained in this right district, if I were just randomly guessing, I know I'm in my community, but I don't know which of the 2 districts I'm in. This uncertainty of membership score would give me a value of 0.926, which I guess doesn't really mean much unless I had given it relative to anything else. But that number just gets higher and higher as your uncertainty increases. So if another district came down and split this right half in half, that value would go up, meaning I'd be more and more unsure about which of the 3 districts I was in if I'm living in that community of interest. Hopefully that helped.
Yeah, thank you.
And so I can also add that these 2 programs are on the RDH GitHub, as well as in the README file on the GitHub. There's a big description about what each program does, where to get the data that you need for it, how to upload it into the program. So if you want any of that in writing, it should be there. And then this is something that's also sort of ever changing because I'm just updating it as people at the RDH think of new ways that it can be improved. So if you start using the program, either one of them, and think it'd be really useful to have some additional information, you could just shoot me an email or anyone at the RDH and it will get forwarded to me. And I could work with you on making that improvement.
Awesome. Thank you so much, Connor. I'll give another chance for if folks have any other questions they'd like to ask, either in the chat or feel free to unmute yourself. I'll give it another moment. I see Jim Lee says, which code repo? I think maybe that's for Connor.
Yeah, sure. Let me just pull it up and I can share the link to the repository.
And I'll also send it in an email later today to folks. Okay, if there are no more questions, like to thank everyone for coming out here today. I know we're just a couple of days from the holidays. Also want to do a huge thank you to Connor and John for coming out today. Thank you so much for hosting this presentation. I hope everyone got a lot out of it. So thank you all so much for doing this. And for folks, I will be sending an email out today. I'll actually send you folks all 3 recordings for the COI trainings. And I know Connor will be dropping the link to the GitHub, but I'll also try to include that in the email as well, so you folks have access to it. If you ever have any questions, please send us an email at info@redistrictingdatahub.org. Let me just put that down. And feel free to send us email. We'll usually reply within 24 hours. But again, just want to say thank you all so much for coming out today. And definitely we'll see you here in the new year with more trainings that are coming up. Definitely excited for that. And yeah, I think we're good. I'll just
Yeah, I can just I'm signed into my GitHub account, so I'm worried that if I just copy the link I have up, it's not gonna work for anyone else. So I'm just gonna send something in a minute to Jose, and then he can email all the participants with that information.
Great. And I will be sending this email out today. So expect that, as well as the 3 trainings for the COIs, the one I did last Tuesday, Thursday, and the one for today. So definitely look out for that today. But again, thank you all so much. Again, thank you, John and Connor, and I'll see you folks in the new year.
Thank you very much for having me.
Bye all.
Thank you. Great, Darlene, I will do that. Thank you, folks. Talk to you soon.